Hey YouTubers, thanks for coming to Man with Beer's channel. I'm just working on a new counterflow chiller. It's an all copper counterflow chiller for my beer system. It's going to be mounted to the brew stand. And I cut all the tubing and everything. I thought about the design for a while, came up with a way to do it. I bought all the materials and I basically pre-assembled it, dry fitted. So it's all set up and ready to go, but I still have to dismantle every section and put the flux on and then solder every piece yet, and that's where I'm at now. I've already done the far side, called it my practice end, and now I'm going to work on this end. So it's a counterflow chiller. Water inlet is here. Just going to be water from a garden hose. Comes in fairly cool here, and it runs through the 3/4 inch exterior copper tube over top of a 1/2 inch interior copper tubing. So it just goes down, works its way to the bottom through the T's into the last section, and then exits out this end here, while the wort will be pumping in through the bottom, and it'll go through each tube, cooling as it gets higher, and then come out here. And I've also got, this is something I've had in the past. This is a air stone, and I'll put a temperature strip on here like we have on our carboys. It'll tell me what the temperature is coming out. And there's just a simple air stone inside here, one of the 5-micron stainless steel stones, attached with some silicone tubing, and then I can hook my air source up to that, and I just use an aquarium pump with a microfilter, and that just threads onto there after it's been cleaned, of course. And then this is going to end up on there, and so my wort will come out here, and I'll be able to recirculate it back to the kettle, and then eventually right into my fermenters when I reach the temperature I want. It's an evolution of what I used to use, the coiled tube with poly plastic tubing, and I had 3/8 inch copper inside that, and it was kind of slow because it's 3/8. My whole pumping system is all 1/2 inch, and I wanted a 1/2 inch chiller, and this was my solution. This way I don't have to set it up or anything. It's permanently going to be mounted right to my brew stand. So I'm going to show you steps in what I've done to put it together, and I'm going to solder one end here, and you'll be able to see the steps involved in that. So I wanted to go over parts and tools that you need to kind of put together aluminum copper chillers of any type. You're going to need a few basic tools. Number one is a tubing cutter. It'll whatever size you need to cut the tubing. This is just a small one meant for 1/4 inch diameter to 1/2 inch, or 3/4 inch actually, 7/8 inch even. But that's just a basic tool, fairly cheap at hardware store. Of course, you're going to need measuring tape. When you're working with copper, you want a file to take off any burrs that might be on there so they go onto fittings. Of course, when you're soldering, wear some safety glasses to protect your eyes. You need something to remove the camphor that exists in the tubing after you cut it, and I just use this thing. I don't know what it's actually for, but it works really well at taking off the rolled copper inside the tubes. It's some sort of a step drill. I bought this for another project, and it works great for the copper. To do this center hole punch thing in the end caps, like I was saying, you need a step drill, and step drills usually come in a set. This is a step drill here. You can see it's multiple steps, and handy tool. I think everybody who does any kind of frequent projects should have something like this. So this will make a nice round hole. And it wasn't exactly the size I needed for this, but a little bit of sanding, and I got the diameter just perfect with that. So the step drill was a must-have for this project, really. You're going to need a few basic tools for soldering. Of course, some solder, lead-free solder, always lead-free when you're working with anything that's potable. This is water-soluble tinning flux. You need flux on the copper and a fluxing brush, acid brush they call it. And then of course this is a fitting tool for 1/2 inch. So you go in and just remove any oxidation inside the fittings with that. Real handy tool, especially for 1/2 inch, because you can't get your hands or your finger in there, or at least I can't. For the bigger fittings, I didn't bother to buy the 1/2 inch brush. I just roll up sandpaper like so, and then stick it inside the fitting with my thumb in there, and just run it through a couple times like that, and remove any oxidation and make some bare metal, make it nice and shiny. And that way the flux and the solder will have something to grab onto. The solder won't grab onto oxidized copper very well, so you have to clean the copper before you use it. And of course, you want a nice long strip of sandpaper like this. This is just a piece of black sandpaper. Long strip to clean off the tubes and solder them. Doesn't actually take much, but you want it nice and shiny like that. Remove the copper oxidation. Probably need a couple of pliers of various sorts to be able to, you know, when you put dry fit fittings in there, they might stick on you. Pliers will help you pull them apart. And then of course, some sort of a flame. Propane torch is fine, or 3/4 inch and down. You can use MAP gas as well. It's a little bit hotter and kind of a must-have for anything over 3/4 inch. But being that this is only 3/4 inch, it's all good. I also want to mention that the 3/4 inch pipe I have isn't the type of pipe that's used in like house plumbing. It's a lighter gauge, so the inside diameter is larger, so that I can have more space between the 1/2 inch and the 3/4 inch, which is where my cooling water is going to run. If I used regular, I think it's type K, if I used the regular, the code style for plumbing in a house, it's quite a bit thicker. And so I wouldn't have as much space between the 1/2 inch and the 3/4 inch, which worked out great anyways, because copper tubing is really expensive. And the lighter gauge stuff is about 1/3 less than the code stuff. So if you're going to do something like this, it's not, you know, part of your house, so you can buy the lighter stuff and you'll get away with that just fine, and it's going to save some money. The 1/2 inch tubing though just wasn't available in a non-code type, so I just got the regular 1/2 inch for, you know, plumbing in your house and stuff, and pay full price for that, but whatever. And that's really about it. Tool rundown, and well, I showed you how to clean your fittings with the sandpaper. Make sure they're all done properly, and all your pieces have to be nice and clean before you put the flux on. And once you put the flux on, then it's okay for a while. It won't oxidize on you again, and you're that much closer to soldering. Okay, had a bit of an interruption. Had to change my batteries there. So as I was saying, everything is all fluxed now, and now we can reassemble and go into soldering mode. This first piece will be a little bit tricky because the end is loose, of course. I'll line everything up, kinda. These go on first. So where this is touching the copper pipe is the trickiest part of the soldering job, because there's no fitting to actually solder here. We're just going to seal this very close edge that I have. It's fairly tight. These pipes just barely fit through that hole. So we're just going to seal that with solder. It's a technique I've used in other projects in the past and it's worked out quite well. So I don't expect any problems, leaks or anything. Just gotta get these back together and lined up. Oops. So, and squeeze it all together. Okay. Good. That's where it's going to sit. I'll clean my hands so that flux. Alright. Now, lots of videos on YouTube on soldering. But basically, you want to heat everything here evenly because everything is going to kind of get soldered at the same time. I'm going to work from this end out to this end, go from the heaviest pieces to the lightest pieces, because as these heat up, all of the rest is going to heat up with it, and it won't take much heat to actually finish the soldering on these little half-inch pieces. So I'll work from here to here. Just warming it up. Alright, there's the finished product mounted on the brew stand. It's just temporarily mounted right now with zap straps. I wanted to test it with some water under pressure, check for any leaks. There was a couple of leaks on the T's that were fairly simple to fix for me. So that's where my air stone will go, and the wort outlet here, air stone, and that'll just go right into this brew kettle on a recirc. This is the cold water inlet, and down at the bottom, use my foot to point, that's the the cooling water outlet, and then the wort inlet down there, and that'll get pumped in the upwards direction. So it should work just fine. I'll have to do a CIP on it, a PBW or hot boiling water, run that through the half-inch line, get it all clean, rinse out the flux, any other residue that might be in those pipes. That'll be done before I brew next. There's my stockpile of green, and that's that project complete. Thanks for subscribing. Cheers.